In this video, I'm going to show you how to scrape Twitter data using Python so that you can mine the data for research, machine learning, sales leads, or whatever you want to use the data for. Twitter is a bit more complex to scrape than some of the other projects I've done so far in this series, and you might ask, hey, isn't there a Twitter API? Yes, there absolutely is, and if you're okay paying for the API access or working within the strict limitations of a developer account, it's definitely something you should check out because it's going to be easier and you'll have a lot more rich metadata available to you. However, if that's not an option for you, then keep watching. We need to automate the browser for this project, so we'll be using SELENIUM. I'm going to assume that you already have it installed, but if not, check out my video on installing SELENIUM. I'm going to use the Edge browser, but you can use any SELENIUM WebDriver you want, such as Chrome or Firefox. There aren't many differences, and I'll point them out when I see them. Here are a few things we'll be tackling in this project. Logging into Twitter. Yes, we need to log into Twitter to scrape the data, so you'll need to get a Twitter account. Continuous scrolling. Twitter handles pagination by continuously loading data as you scroll down the page. This is different than typical pagination where you can simply click on the next page or get a link to the next page. I'll be using a lot of XPATH syntax because using XPATH is the absolute simplest and most effective way of getting the elements on a complicated website like Twitter. The first thing you need to do is import the required libraries. If you're using Firefox or Chrome, your WebDriver imports will look the same except for one key difference. You'll import the Firefox and Chrome WebDrivers instead of using the MS Edge SELENIUM Tools library. Next, create an instance of the WebDriver. Now this will be different depending on your WebDriver, as I've indicated here. A web browser should open up now, and you can use the get method of the driver to navigate to the Twitter login page. What you should see now is the Twitter login screen, and what we need to do is find the username and password input boxes, fill them in, then submit. Right-click the username input box and then click Inspect. You'll see the developer tools open up on the right-hand side or the bottom of your screen depending on how you have it set up. You may need to click Inspect on the input a few times to get to the right level of detail. What you should see now is an input tag that has a lot of stuff in it. But one of the properties is called name, and it has a value of sessions, and then username or email in brackets. This is what we need to identify this element. As for the password, if we right-click and then click Inspect, you'll see another input element, and this one has a property called name as well, and the value is session with password in brackets. So let's take this information to our code editor and log into Twitter. Use the method findElement by XPATH, and pass in the following string, which I'll explain. I'm not going to give a full XPATH tutorial, but I do have a link in the description for some resources if you'd like to learn more about it. I highly recommend it. You might be able to tell already what this means. Now, a single forward slash means that I'm starting from the root of the document. However, a double forward slash means that I'm looking for something that starts anywhere in the document. I'm looking for an input tag with certain qualifications that I've included within these brackets. In this case, it should have a property called name with a value of session and then username or email. Then assign this to the variable username. Then use the sendKeys method to input your username. You should now see your username entered into the input box. Now for the password. Because I don't want to hardcode my password on the screen for all to see, for obvious reasons, I'm going to use the built-in getPass function in the Python standard library. It essentially works like the input function except that it hides the input from the user to keep it private. Let's find the password input the same way we found the username input, except this one has a name value of sessions password. Then use the sendKeys method to enter your password. Finally, you can use the sendKeys method again to send the return key, which is essentially the same action as clicking the login button. Alright, now if everything went as planned, you should be logged into your Twitter account. What we need to do now is search for some term that we want to extract data for. At the upper right-hand corner of the screen, there's a search input box. Right-click on that input box and then click Inspect. This one appears to have a few properties that we can use, such as the area label that has a value of search query, and the data test ID that has a value of search box search input. But we're going to go ahead and go with the area label because it's shorter. Same as before, use the find element by XPATH method to find the input tag that has an area label with a value of search query and assign this to a search input variable. Next, use the send keys method to enter a search term into the input box. I'm going to type in #polynote, then use the send keys method again to send the return key. Now, you'll notice that at the top of the page you have a few tab options, such as Top, Latest, People, Photos, Videos. You can find and click any of these tabs with your WebDriver depending on your goals. However, since I'm interested in pulling historical data, I'm going to go ahead and click on the Latest tab with the WebDriver. So right-click on the Latest tab link and then click Inspect. As you can see, this is a tag with other stuff embedded, but it looks like the easiest way to identify this may be to just search for the text of the link. Now, fortunately, there's a built-in function for this called Find Element by Link Text. So use this method and then click on the link to navigate to the Latest tab. The next thing we need to do is figure out how to collect all the tweets on this page, and I like to refer to them as cards. Now, because this is a continuously scrolling page, there's only about 9 or 10 tweets loaded so far, but as I continue to scroll down the page, more and more tweets will load. So the process of scraping these tweets is going to be an iterative process of scraping and scrolling. Right-click on a tweet, and let's see how we can identify it as a unit. As you scroll down the code, you'll notice that different elements of the page are being highlighted, and this tweet has several layers of containers. However, there's a div class container that has a data test ID with a value of tweet. This looks like it's going to be our ticket. So let's go back to the code and collect all of the tweets on the page. Use the find elements by XPATH method to find all div tags that have a data test ID value of tweet. Notice that the method is plural, elements, and not element. This means that I'm going to return a list of elements and not a single element. Assign this to the cards variable. Then, get the first card in the list so that we can begin prototyping a data extraction model on a single card, which we can then apply to all of them. Now, if you take a look at this tweet, there's a few pieces of information that we want to collect. So we have username, Twitter handle, timestamp, count of comments, count of likes, count of retweets, and the text of the tweet itself. Of course, the containing div tag is the one that contains the tweet test ID, which we've identified. One of the difficulties with scraping Twitter data is that you don't have access to a lot of unique identifiers that allow you to quickly access the data you want. So a lot of what we need to do is rely on relative relationships. So if we drill down one level into this tweet, you'll see that there are two divs. The first one contains the user image, and the second one contains the body of the tweet that you can see on the right-hand side of it. We can access that body by using the following XPATH notation. The period here means that the search is starting from the current element. Then we're looking for a div tag, and then since there are two, we can use the brackets to access the second one. So I'll put a 2 in here. If we drill in one level into the body div, you'll see that there are two more divs. The first one contains the username, Twitter handle, and date, and the second one here contains the content of the tweet as well as the count of tweets, retweets, etc. So let's go ahead and grab the username, Twitter handle, and post date. Now we already have that second div containing the body of the tweet, so to get the first div tag within that one, we can access the next node in a similar way, except this one will be the first element of that node, and so we'll use a 1. Now to get the username, let's start drilling down and down and down. Okay, this is a bit ridiculous to be honest. So at the end of the day, this username is in a span tag Fortunately, with XPATH, we can skip all of this and go straight to the first span tag by using double forward slashes and then a span tag. So putting this all together, we can use the find element by XPATH method with this XPATH to get the username. And then we'll grab the text. Now I wanted to show you how to slice a node here if you hadn't seen this before, but we can actually shorten this a bit further. Since this span tag is the first one in this tree, we can just use the following abbreviated XPath command that means give me the first span tag after the current tag. The next item that we need is the Twitter handle. Now, if you drill down in this more, you'll see that the Twitter handle is located in a span tag as well, and it will be the first span tag that contains an @ symbol. So we can use a little XPath magic to make this really simple. So using the find element by XPath method, we're going to look for the first span tag that contains text with an @ symbol, and then we'll return the text of that element. The next element is the post date, and this one is actually pretty easy. The post date is located in a time tag, and it has an attribute called datetime, which represents the timestamp of the tweet. Now you can use the datetime library of Python to convert this to a datetime object, but I'm just going to leave it as a timestamp string. The next item is the text of the tweet. Now, we actually already know where this is. You saw before that the card contains 2 div tags, and then in the div tag that contains the tweet body, 2 more div tags. And it's that second one that contains the content of the tweet and the tweet stats. However, we can't just grab the text of that second div, otherwise what we'll do is we'll end up picking up the likes and retweets and all that, and it's going to show it up at the end of the text. If you drill into that second div, you'll find 3 more divs. The first is the user comments. The second is the content that the user is responding to. And the third is the group of tweet stats and other buttons at the bottom. Now, as far as I know, these 3 divs will always exist, even if the person is not responding to anything. It's just that it will be empty if there's nothing they're responding to. So what we're going to do is grab the first 2 divs separately, and then we'll concatenate them together to represent the content of the tweet. Alright, the last 3 items are the reply count, the retweet count, and the like count. Now these are easy to get because they have attributes that can uniquely identify them, as you can see in this code. So use the find element by XPath method on the card element and extract the counts for reply, retweet, and likes. Now if there are no counts for these, it will just return an empty string, which is fine. Now that we've prototyped a model for a single tweet, we can generalize this model by creating a function with all of the code that we've written up to this point. So create a function called getTweetData that accepts a single argument, card, and then copy and paste all of the code above. One thing I should point out is that if you look through these tweets, occasionally you'll see sponsored content. The thing about sponsored content is that it doesn't contain a post date. So what's going to happen is, in these cases, we're going to try to get a date time element, but the element's not going to exist. So it's going to return a no such element exception. But this is actually a good thing because it means that we can easily filter out sponsored content by handling this exception when we try to get that post date. We're going to then consolidate this into a tuple and then return that tuple, which is basically the tweet data. Now you can test the function on your card. To apply the model to all cards, simply write a for loop that appends the results of the function to a tweet data list if there's any data returned. Then print the first item in the list to see that it returned out as expected. As I mentioned before, one of the challenges of getting data from a website like this is that it's got a continuously scrolling page. The data continues to load as you scroll. So in order to do this, we need to actually execute a bit of JavaScript to tell the browser to scroll down the page. But don't worry, it's very simple, and all you need to do is copy and paste what I'm doing here. This bit of code will scroll down to the bottom of the page, at which point more content will load to the screen. So now we have all the pieces that we need to create our Twitter scraper. So let me quickly outline how this is all going to work, and then we can put it all together. So first, we're going to import the required libraries. Then we're going to define our getTweetData function. We're then going to start up the WebDriver. Then we'll navigate to Twitter and log in. We'll enter our search term, and then we'll extract all available tweets. We'll scroll down, and we'll repeat that process until we've extracted all of the tweets on the page. This loop we wrote to extract the card data works for a single page. However, there's some optimizations that we need to make for it to work on a continuously scrolling page. First, as we continue to scroll the page, the background HTML isn't necessarily going to disappear. Now, what's going to happen is it's going to continue to grow. So instead of finding 10 tweets on the page, it might find 20, 30, etc. It doesn't necessarily grow consistently, but the fact is it does grow. So what this means is that there's potential to continuously scrape tweets that we've already scraped. There are two things that we can do to fix this. First, instead of iterating over every page card in our page cards list, we'll just look at the last 15 items. This will save us time by not having to recheck every single tweet in the list when we know that really only the last 15 or so are the ones that we care about because they're the new tweets that have been loaded onto the page. The next thing we can do to prevent from duplicating tweets is to keep track of the tweets that we've already scraped. Now, unfortunately, we don't have a tweet ID, but we can create one by concatenating elements of the tweet into one long string, which essentially creates a unique identifier. Then what we'll do is check to see if that tweet ID has already been collected by checking it in a set of tweet IDs. And if not, we can append that tweet to the tweet data list and also add that tweet ID to the tweet ID set. Next, let's add the pagination. Now, every time we page down, I'm going to cause the program to sleep for 1 second. This will give the program time to load before I start scraping the data. Now, what we have is a loop that will continuously scroll down the page and then scrape additional tweets. However, you might be able to see a problem. We don't currently have a way to test whether or not we've reached the end of the scroll region. Now, the key here is to always keep track of the Y position of the scroll bar using a little piece of JavaScript code. We'll track the position before and after the scroll, and if the scroll position doesn't change, we'll know that we've reached the end and then we can break out of the loop. The first instance of this code is going to go right in front of the while loop, and we'll call this variable last position. The next instance of this code is going to be right after we scroll down the page, and we'll call this variable current position. Then what we'll do is compare the current and last position, and if they're the same, we'll break out of the loop. Now, as it is, this will work, but sometimes it won't. Unfortunately, the internet is not always as speedy and consistent as you'd expect it to be, so sometimes you'll execute a scroll down and it won't load fast enough, so the starting position and the ending position will still read as the same. This will cause the script to stop prematurely. So what we can do to fix this is allow for a certain number of scroll attempts before it finally breaks the loop. To implement this fix, we'll insert a variable called scrolling, and set it to true. We'll insert this before the while loop. Next, instead of while true, we're going to change this to while scrolling. Then we're going to create a variable called scroll attempt and place it right before the code that we use to scroll down the page, then set it to 0. Now we're going to put this scrolling code inside of a while loop. So while this is true, we're going to scroll down the page, pause, then evaluate the current and last position. If the current and last position is the same, we're going to increment the scroll attempt. If the scroll attempt is greater than or equal to 3, we'll go ahead and set scrolling to false, and this will break us out of the outer loop. We can go ahead and break this inner loop for completeness. Now, if the scroll attempt is less than 3, we want to sleep for 2 seconds, and then it will continue to cycle through this loop, trying again to scroll down the page. If the current position is not equal to the last position, this means we've successfully scrolled down the page, and we can reset the last position by setting it to the current position. We can then break out of this inner loop of scrolling and get back to this outer loop of scraping tweets. Now we can let our bot run until it's finished scraping all of the tweets. After the scraper is finished, you'll want to save the data. You can use the CSV library to do that, or if you want to use something else, that's fine too. And that, my friends, is how you scrape tweets from Twitter. I hope you've enjoyed this video. If so, please make sure you hit that like button and subscribe to see more content like this in the future. See you in the next video.